Say you are learning methods. Before going to methods, how many people completed assignment? Just raise your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Online students. 18, 19, 20, 21. Okay. At least 5 programs. How many people completed? 5 programs. Okay. Say whether you are getting output or not, but you have to try. If you don't try, you will not get a skills. You have to try. Now, the assignment programs I'll explain. You observe. Uh, Assignment program. First, first program. Write a program to display factors of a given number. That is a given. Okay. Say, write a program to display factors of a given number. First of all, one number you have to accept. One number you have to accept. For accepting one number, already given scanner class. What we have to write? Scanner is equal to new scanner system dot in. Scanner class in which package? Java dot util package. How to import? Import java dot util dot star. What is the meaning of star? All classes and all interfaces. Instead of star, can I write only scanner like this? Yes, it is also valid. Okay. If you write like this, only scanner class imported. If you write star, all classes and all interfaces imported. Okay. If you write like this, all classes and all interfaces imported. If you write here scanner, only scanner class imported. Anyone you can use. Now star I'm writing. After this, next what we written? System dot out dot print. Print I'll write. Print ln means next line. Print means same line. Enter any number. Will accept one number. That number if you want to accept one variable. Int a equal to s dot next 10. This is first accepting one number. Okay. It is first program. Write a program to display factors of a given number. Given number is stored in A. Now, suppose this number is 25. That means 1 to 25. 1 to 25 equal to 1 to 25 you have to check the factors. If the number is 8, then you have to check 1 to 8. 1 to 8. Okay. Now, further one loop required. If the number is 25, 1 to 25. If the number is 8, 1 to 8. If the number is 40, 1 to 40. Further, one loop required. What we have to write? For int I equal to 1. I less than or equal to a. I plus plus. That's it. One loop. If the number is 25, the 25 is stored in A. So you entered 25. The 25 is stored in A. It is 1 to 25. If you suppose if you enter 8, it is stored in A up to 8. If you enter 40, up to 40, like this. Now each number, whether it is factor or not, you have to check. How to check? If A modulo division I, double equal to 0. Here a value divided with 1. Remainder. If remainder is 0, that is factor. If it is factor, display that output. System dot out dot println I. Then factor printed. File save. Okay. Now file save. Okay, saved in E drive. Okay. In E drive means we have to enter into E drive. Now command prompt. I saved in E drive. That's what I'll go to E. E drive. Java C demo.java. Compilation. Scan the spelling mistake. 3 N's are written. No. Compilation. Execution. See, enter any number 8. 8 factors are 1, 2, 4, 8. Suppose Java demo 25. 25 factors 1, 5, 25. Okay. Java demo 6. 6 factors 1, 2, 3, 6. Say 1, 2, 3, 6. Java demo 5 factors 1 and 5. This is factors program. Write this one. Here program to display factors of a given number. Program to display factors of a given number. Write the program. Program to display factors of a given number. Program to display factors of a given number. Say in this line a value accepted. Okay, in this line a value accepted. Suppose a value 6. Tracing also I'll explain for this program. Just you observe. A value 6. Then I equal to 1. So I value 1. Say in this line a value accepted. A value suppose 6. Next, I equal to 1. So I value 1. 1 less than or equal to 6. 1 less than or equal to 6. It is true. 1 less than or equal to 6. It is true. Then 6 modular division I. 6 modular division I. Nothing but 1. 1 6 ja 6. 1 6 ja 6. Remainder 0. See, 1 6 ja 6. Remainder 0. Now 6 modular division 1. 6 modular division 1. So 1 6 ja 6. Remainder 0. 0 double equal to 0. True. Then output printed 1. So output 1. 1 printed. After printing 1, from here, control comes to I plus plus. Now I becomes 2. I becomes 2. Then 2 less than or equal to 6. 2 less than or equal to 6. True or false? True. So it is true. Then it will come here. 6 modular division 2. 6 modular division 2. 2 3 ja 6. Remainder 0. Remainder 0. Okay. 2 3 ja 6. Remainder 0. So 0 double equal to 0. True. System dot out dot println I. What is output? 2. Next I plus plus. I becomes 3. 3 less than or equal to 6. 6. 3 less than or equal to 6. True. Then 6 modular division 3. 6 modular division 3. 3 2 ja 6. Remainder 0. 6 modular division 6. 0. Remainder 0. 0 double equal to 0. True. Then system dot out dot println I. 3. Next I plus plus. It will become 4. 4 less than or equal to 6. It is true. Then 6 modular division 4. 6 modular division 4. 4 1 ja 4. Remainder 2. 2 double equal to 0. False. Here 2 comes. 2 double equal to 0. False. Then it won't print. It won't print. I plus plus. I becomes 5. 5 less than or equal to 0. It is true. Then 6 modular division 5. 5 1 ja 5. Remainder 1. Remainder 1. 1 double equal to 0. False. It won't print. I becomes 6. 6 less than or equal to 6. True. 6 less than or equal to 6. It is true. Then 6 modular division 6. 6 modular division 6. 6 1 ja 6. Remainder 0. Remainder 0. Then 0 true. Then it is printed. After that I becomes 7. 7 less than or equal to 6. Stop it. So output 1 2 3 6. This is factors of a given number. First a value accepted. Suppose a value 6. I value 1. 1 less than or equal to 6. True. It will enter 6 modular division 1. 0. 0 double equal to 0. True. Then 1 printed. After that I becomes 2. 2 less than or equal to 6. True. 6 modular division 2. 0. 0 double equal to 0, true. 2 printed, it will become 3. 3 less than or equal to 6, true. 6 modulo division 3, 0. 0 double equal to 0, true. Printed. I becomes 4. 4 less than or equal to 6, true. 6 modulo division 4. Reminder? What is the remainder comes 6 modulo division 4? 2. 2 double equal to 0? False. It won't print. I becomes 5. 5 less than or equal to 6? True. 6 modulo division 5? 1. 1 double equal to 0? It won't print. I becomes 6. 6 less than or equal to 6? True. 6 modulo division 6? 0. 0 double equal to 0? True. Then 6 printed. After that 7. 7 less than or equal to 6? False. Stop it. Okay. This is programmed to display factors of a given number. Okay. Now, any number you enter, that number factors displayed. Compilation. Execution. See, suppose one number 876. 876 factors also displayed. Now 1 to 876, each and every number factor or not, it will check. If it is factor, printed. This is factors of a given number. It is first program. Second program, what I given? Write a program to accept one number and display some of the factors. Display some of the factors. Now, what is the difference you observe? Here factors we are displaying. Now, we should display some of the factors. Suppose 6 factors. 6 factors are, you have seen. 1, 2, 3, 6. This sum we have to display. 1 plus 2, 3. 3 plus 3, 6. 6 plus 6. This is I want output. Suppose number is 5. 5 factors are 1 and 5. Some of the factors are 6. Suppose 28. 28 factors are 1. Next 2. Next 4. Next 14. Okay. 14 plus 20. Next 28. Say 1 plus 2, 3. 3 plus 4, 7 plus 7, 14 plus 14, 28 plus 28, 56. We want like this. If I enter 6, output should be 12. If I enter 5, output should be 6. If I enter 28, output should be 56. This is our requirement. Say, what you can do is, one variable you can take. One variable, sum. Integer sum. Okay. But it is local variable. Local variable must be initialized before access. Say, here, suppose, here what I will do, sum equal to sum plus I. So, if it is factor, that factor we are adding to sum. First, initially, what is sum? Not 0. It is local variable. Local variable must be initialized before access. Otherwise, compile time error occurs because it will not get default value. That is, you studied, no point. So, I written sum. Here sum plus I. But sum is nothing. First, sum is not there. Error comes. You cannot access. See, compilation. See, variable sum might not have been initialized. Without initialization, you cannot access. So, that's what I'll do. Sum equal to 0. Myself I am writing. It is local variable. Local variable must be initialized before access. Otherwise, compile time error occurs because they do not get default values. This note's already given. Instance variable will get a default value. Class variable will get a default value, but local variable will not get. Okay. That's what sum equal to 0. Now what will happen? See, first sum value 0. Then here factor value added. Like that, total iterated when last sum comes, when for loop terminated, system dot out dot println sum. Now sum of the factors. This variable name not only sum, whatever you want you can take. This variable name whatever you want you can take. If it is factor added, see suppose now 6. Suppose a value 6. A value 6. Some value 0. Suppose you observe here a value 6. Here some value 0. A value 6, some value 0. I value 1. 1 less than or equal to 6 true. 6 modulo division 1. 6 modulo division 1. 0 double equal to 0 true. Then sum equal to sum plus I. I value 1 is there no? I value 1. Sum equal to sum plus I. 0 plus 1, 1. Now after this, I plus plus. I becomes 2 less than or equal to 6. True. 6 modulo division 2. 0. 0 double equal to 0. Then sum equal to sum plus I. 1 plus 1. If you give answer, you'll get a subject. Okay. See, all people not completed assignment. And even 5 programs also not completed all students. But I'm explaining again, you observe. These all already logics you studied. With that knowledge, you can write these all. It is possible. Already many logics I explained. With that knowledge, you can do it actually. Now, while asking question, at least give answer. The execution process you'll understand. See, first in this line, suppose a value 6. In this line, what is some value? 0. So sum equal to 0. Sum equal to 0. In this line, what is I value? 1. I value 1. Okay. Now, here 1 less than or equal to 6. True. It will enter. 6 modulo division 1. 0. 0 double equal to 0. True. Then sum equal to sum plus I. 0 plus 1. 1. 1 stored in sum. After this, I becomes 1. I becomes 2. I becomes 2. After this, 2 less than or equal to 6. True. 6 modulo division 2. 0 double equal to 0. Sum plus I. Sum equal to sum plus I. 1 plus 2. 3. 1 plus 2, 3. After that, I plus plus. I becomes 3. I less than or equal to A. 6. I value 3. 3 less than or equal to 6. True. 6 modulo division 3. 0 double equal to 0. True. Then sum equal to sum plus I. 3 plus 3, 6. After that, I value 4. I value 4. 4 less than or equal to 6. True. 6 modulo division 4. 2. 2 double equal to 0. It is not added. Then I becomes 5. 5 less than or equal to 6. True. 6 modulo division 5. 1 double equal to 0. False. Then I plus plus. I becomes 6. 6 less than or equal to 6. True. 6 modulo division 6. 0 double equal to 0. Then sum equal to sum plus I. 6 plus 6, 12. After that, I plus plus. I becomes 7. 7 less than or equal to 6. Then it will come out. Then system dot out dot println sum. What is the output comes? Even those who don't know, first write the program. You trace. Like this, you trace execution process. Where is a mistake? What is a mistake? You can understand. That is required. So first what you do is try to write program. Compile, execute. If you are getting wrong output, that meaning logical error. The logic, you check it with tracing. Where is a mistake? What is a mistake? Find out. Okay. Say file, save. Compilation, execution. Say, if I enter 6, output is 12. Java demo. 5 factors, 1 and 5, output 6. Java demo 28, 56. Okay. Java demo 8. 8 factors are 1, 2, 4, 8. Then 1 plus 2, 3. 3 plus 4, 7. 7 plus 8. You are getting no? Write this program. Program to display sum of the factors of a given number. See that program to this program, one line different. Sum equal to sum plus I. That's it. Write this program. Program to display sum of the factors of a given number. Program to display sum of the factors of a given number. Program to display sum of the factors of a given number. If you know the logics, any program you can write. So the execution process, you have to observe, you have to think, you have to write. If you are getting wrong output, trace. Line by line, word by word, trace. You'll get it. That is you have to follow. Program to display sum of the factors of a given number. So this second program. First 5 programs I'll explain. I'll give one more day time. You try to complete by tomorrow. Five programs I'll explain. Then I'll start remaining concepts. Previous concepts, last class methods I started. No? Methods I'll continue. Just 3 more programs I'll explain. After that, methods I'll continue. One more day time I'll give. Try to complete. See, first program to second program little bit different. No? So previously what we did here, system.out.println I. Now we are adding to sum. That's it. Now third program also same, little bit different. Third program also same. You observe. First 5 programs, first 8 programs same. Next to 4 programs same. I think 12 I given in assignment. Out of 12, first 8 programs same style. Little bit different. Program to program, little bit different. Same. It is second program. First program displaying factors. Second program displaying sum of the factors. So previously here system.out.println was there. Now sum equal to sum plus I. If it is factor, we are adding to sum. When for loop terminated, we are printing. This is second program. Third program. Write a program to check whether given number is perfect number or not. That is third program. If you want to check perfect number or not, sum of the factors, if it is equal to given number, that is called perfect number. See, for example, 6. 6. 6 factors are 1, 2, 3, 6. 6 factors are 1, 2, 3, 6. In this, except 6, except last number, given number, 1 plus 2 plus 3, you'll get a 6. So, it is nothing but perfect number. Okay. Suppose 5. 5 factors are 1, 5. 1 plus 1 except 5. Except 5. Now, it is not a perfect number. Suppose 14. 14 factors are 1, 2, 7, 14. Except 14. 1, 2, 7. 1 plus 2, 3. 3 plus 7, 10. It is not a factor. Okay. It is not a perfect number. Suppose 28. 28. 1, 2, 4, 7, 14. Next 28. Except 28. Then 1 plus 2, 3. 3 plus 4, 7. 7 plus 7, 14. 14 plus 14. It is a perfect number. Like this. So what you have to do, this sum we calculated, no? This sum. But except that number means what you have to do here? I less than A equal to I removed. Now you'll get a sum. If that sum equal to A, that is perfect number. System.out.println, given number is perfect number. Else system.out.println, given number is not a perfect number. So if it is the sum equal to given number is a perfect number. Given number is not a perfect number. That's it. You see, file, save, compilation, execution. Say 6, perfect number. Java demo 5. 5, is it perfect? No, not a perfect number. Now 14, not a perfect number. 28, perfect number. Like this. Ready, son? Program to check whether given number is perfect number or not. If you want to write more than one line comment, you have to write like this. Program to check whether given number is perfect number or not. More than one line is there, you have to write comment like this. Program to check whether given number is perfect number or not. Noted? Online students, end of the session and clarify your doubts. Listen the class, write the notes. Program to check whether given number is perfect number or not. Single line comment is there, two forward slashes. More than one line comment is there, forward slash star, starting point, ending point, star, forward slash. That is the syntax. See, first program to second program, little bit different. Sum equal to sum plus I. Second program to third program, just little bit different. Sum double equal to A. Sum of the factors, if it is equal to given number, that number is called perfect number. That is perfect number or not, we are displaying. Is it over? Now the third program. Fourth program, program to displace all perfect numbers between 1 and 1000. 1 and 1000. Now, here, if sum double equal to A, suppose, if sum double equal to A, it is perfect number, no? Now what I'll do is, I'll remove this if else statement. I'll write system dot out dot println A. I'll write. What will happen? If it is perfect number, that number only printed. If it is not a perfect number, that number not printed. Okay. See, compilation, execution. 6. Is it perfect number? Then what is the output comes? 6. Java demo. Is it perfect number? No, you will not get output. This is what I will do. You observe. I'll remove this scanner class. Now, this is also I'll remove. Now, for loop, integer a equal to 1, a less than or equal to 1000, a plus plus. Now, each and every number, whether perfect or not, it will check. If it is perfect, print it. Over. Now, what will happen? This logic I written in a for loop. What will happen? 1 value, 1 a value, it will check. If it is perfect, printed. If it is not perfect, not printed. That's it. Logic I written in one loop. That's it. See. Now 1 to 1000. What are the perfect numbers are there? Those are displayed. Only 3. 1 to 1000, only 3 perfect numbers are there. 6, 28, 496. Remaining all not perfect numbers. This is fourth program. That's it. Program to program, little bit different. Now, what is happening? It first a value 1. Is it perfect or not? It will check. If it is perfect, print it. Then a value 2. Is it perfect number or not? It will check. If it is perfect number, print it. 3. it will check. 4, it will check. 5, it will check. 6, it will check. Like this, it is going to check. Say 1, not a perfect number. 2 is not a perfect number. 3 is not a perfect number. 4 is not a perfect number. Next 6. After that 28. After that 496. Write this program. Program to display all perfect numbers from 1 to 1000. Program to display all perfect numbers from 1 to 1000. Program to display all perfect numbers from 1 to 1000. Just a perfect number logic I written inside the for loop. That's it. Is it over? So a value 1 to 1000, one loop. One value, whether it is perfect or not, it will check. If it is perfect, printed. This is fourth program. Writing is over. Now fifth program. Write a program to display factors, perfect numbers in a given range. Now your range is 1 to 1000. This one accept dynamically. That's it. Now you observe. Program to display all perfect numbers in a given range. Range you have to accept. See scanner class. What you have to write? Scanner is equal to new scanner. System.in. Now starting point, ending point we required. Now starting point 1, ending point 1000 in previous program. Now starting point, ending point accept. Next. System.out.println. Print. Enter starting number or where you want to start something. Next. Integer variable name start equal to s dot next end. Same system.out.print. Enter ending number. Integer end s dot next end. Now here a equal to 1 place. What you have to write? start 1000 place and over given range remaining all same, no change. File save. Say compilation execution. Now where you want to start, suppose 100, where you want to end, 200. 1 minute. 1 to 1000, 1 to 1000 no perfect numbers, that's what, no output. Suppose 1 to 500, three numbers are there. Suppose java demo, 500 to 1000, no perfect numbers. Java demo 1000 to 5000, no perfect numbers. 1000 to 10,000, one number is there. 8128 also perfect number. Okay. Now this is fifth program. Note. See, program to program little bit different I given. First 5 programs same style you observe. All some factors based logic only. But you have to try. If you don't get, I'll teach. But you are not trying means you will not get a skills. Your answer right or wrong, you have to try. If wrong output comes, trace. 1 time, 2 times you trace. Still, if you don't get, I'll teach, then you can follow. But everyone should try. Five programs completed. This remaining 7 program, at least you try to complete by tomorrow. Now I'll teach methods concept. Is it completed? Five programs over. Remaining 7 programs you try to complete by tomorrow. Okay. Later I'll discuss one more day. I'll discuss about the remaining 7, but you try to complete by tomorrow. See, sixth program. Write a program to check whether given number is prime number or not. What is prime number? That's it. One and itself. No other factors. Suppose five. Five factors are 1 and 5. Is it prime? Yes. 1 and given number. Those two only factors. That is called prime. Seventh program, display prime numbers from 1 to 1000. Again, same logic. No? Just one loop you outright. And eighth program, display prime numbers between in a given range. Starting number, ending number, accept. Write that loop. That is eighth program. Ninth program, to display digits of a given number. See, digits, suppose 532 is there. 532 you have to display. That is 532 also okay, 235 also okay. Digits. So output should be 235 or 532 digits. Like this. Either 235 or 532 digits you have to display. Okay. That is one logic. That is display digits. Later, sum of the digits. So 10th program, sum of the digits. Okay. After that, display reverse. If the output is if the number is 532, output should be 235. After that, palindrome. Palindrome nothing but if you reverse, again if it is equal, that is called palindrome. Suppose one number 8448. It's a number. If you reverse, what will happen? 8448. That is called palindrome. Again, 4 logic, same style. You observe 8 program, one type. 8 programs are based on factors only. Only factors. Perfect number, factors concept only. Prime number, factor concept only. Okay. 8 programs are given only based on factors. Remaining 4 program to separate digits. Division, modular division you can apply. Modular division by 10, you will get a 2. Modular division by 10, you will get a 3. Modular division by 10, you will get a 5. That is division, modular division, 2 operators you can apply, you can do it. That's it. These all you try to complete. Okay. By tomorrow. Now, next our concept continuation, I'll show you methods. You are learning methods.
Recording in progress.
Okay, these all I explained. Once again, you observe here what I given. See, a group of statements into a single logical unit is called a method. See, these two statements group put together as a one unit. This unit is called method. These five statements group put together as a one unit. It is also method. Here, two statements group put together as a unit. It is a method. Here, five statements group put together as a unit. It is called method. Okay. Methods are used to perform the task. Here, we are performing the task is addition of two numbers. Methods advantages are two advantages: modularity, reusability. Say this application task divided into two parts. It is one module. It is one module. Module wise divided. If you divide, reusability comes. This method n number of times you can access. That is a benefit with modularity. So it is also benefit. It is also benefit only. There only. Four categories of methods are there. Okay. It is first category method you are learning. Now, like an instance variable, class variable, that type only. If the method is defined as a member of a class, it is called instance method. If the method is defined as a static member of a class, that is called class method. So add method is instance method. Main method is class method, because static. Okay. Member of a class, instance method. Static member of a class, class method. Now, here, what will happen? See the execution process. Demo class loaded, open brace executed, main method called, open brace executed, here object created, with that object add method called 81, 43. Then 81 copied in A, 43 copied in B. Result copied in C. C value return. Return value copied in X. That X printed. Again object created, that object referred by D. With that add method called 81, 44 copied in A and B. Result copied in C, return. Return value copied in Y. Y printed. So file, save. If I compile and execute. See, output. This is first category method. See, already explained. If you write like this 81, 43 copied in A and B. Then it will become int A equal to 81, int B equal to 43, or return C. C value copied in X. Then integer X equal to C. Okay. Now, same style again here. 81, 44 copied in A and B. Result copied in C. The value return. Return value copied in Y. Y printed. Okay. This example you already studied last class. Written notes also over. Now, one more example. Suppose method name cube. We are calculating cube. For this one argument A. This argument cube we have to calculate. Integer B equal to A into A into A. This value we have to return. Return B. B which type? Integer type. So here integer type you have to mention. Now here cube is a method which takes one integer and which returns one integer. Cube is a method, it takes one integer and returns one integer. Listen. You are not listening. Two members. See, cube is a method which takes one integer, which returns one integer. Okay. Now, cube is a member of demo class. It is called instance method. How many ways to access? Two ways. What are those? Object reference. You don't concentrate on mobiles. Listen the class. Many times I told, daily if I teach like that, you'll get irritation. Daily if I motivate. Listening is important. Already first class only I said, that is you have to follow. If you concentrate on mobiles, if you discuss with your friends, if you think outside, attending class is wasted. That's it. Even if you write notes also, no use. Notes is nothing. Listening is important. That is only method means attending class is best. Now, here you observe cube method. It takes one argument which returns one integer. Now, you observe here return type. What is there? Int. So int x equal to. Okay. After this, by using object, new constructor, object created with that dot cube. One number you can pass. Then object created to demo class with this object cube method called 5 copied in A, 5 into 5 into 5, 125 copied in B, return B, B value copied in X. That X we have to print. System.out.println X. By using object reference, if you want to call, how to call? Demo D equal to new demo. After this, int Y equal to D dot cube of one number. Next, another number. Next, system dot out dot println Y. Say, demo class loaded, open brace executed. You already studied execution priority. Once if the class is loaded, execution priority applicable. What is the execution priority? Class variables. Next, static blocks. Next, in this program, any class variables are there? No. Next, any static blocks are there? No. Next, main method called. Okay. Demo class loaded, open brace executed, and main method called. After this, here object created, but this object not referred by reference. This type of object is called anonymous object. We can also call unreferenced object. Okay. With that object, cube method called. Then 5. Then 5 copied in A. 5 into 5 into 1, 5, 125 copied in B. Return B. B copied in X. That 125 printed. Again, object created, object referred by D. With that cube method called. 9 copied in A. 9 cube calculated in student B. B return. Return value copied in Y. Y printed. See, file, save. Compilation, execution. 5 cube 125, 9 cube 729. Write this program. It is first category method only. Is it over? It is first category method with arguments and with return value. Methods with arguments and with return value. Say in this program, method components I'll explain. In this program, method components I'll explain. First, is it completed? Writing is over. Now, method components I'll explain. First, listen, don't write. I'll give time for writing. Here, what is cube? Method name. What is NTA? Method name and argument. It is called method signature. Method signature. What is integer? Return type. Return type and method signature. It is called method declarator. Method declarator. Okay. Open brace to close brace. It is called method body. Open brace to close brace. It is called method body. Return keyword line. It is called return statement. It is called return statement. This totally called method definition. Method definition. Method definition. Okay. Now here this line and this line are called method call statements. This line are called method call statements. What are the arguments you are passing in method call statement? This argument is called actual argument. These arguments are called actual arguments. The argument, whatever you passed here, it is called formal argument. It is called formal argument. Write this one. This complete note down. Method components. Is it completed? I'll ask some questions. Give me answer on this diagram. Method name and arguments. Method name and arguments is called method signature. Return type and method signature is called what I given? Declarator. Declaration means semicolon. Semicolon is there? No. I given declarator. Declaration different, declarator different. Method declarator. Declaration in further session it comes. That is abstract method. That is called method declaration. It is declarator. Declaration different, declarator different. It is declarator. I given right properly, right clearly. I given declarator or declaration. See, but right declarator only. Okay, declaration further comes. I'll explain. That is abstract method concept. Now, return type and method signature is called method declarator. Open brace to close brace is called method body. Method body. Return keyword line is called return statement. Method body and method declarator is called method definition. For calling method definition, we written some statements in main method. Method call statements. What are the arguments we passed in method call statement? Actual arguments. What are the arguments we passed in method definition are called formal arguments. Okay. Here, whatever you are passing, actual. Whatever is received, formal. But arguments also you can call, parameters also you can call. Actual parameters, formal parameters, like that also you can call. So here in the brackets, parameters also you can write if you want. Arguments, parameters both are same, synonyms. Here actual arguments or actual parameters. Here formal arguments or formal parameters. So arguments and parameters both are same. Actual arguments, actual parameters, formal arguments, formal parameters, like that you can call. Okay. Now, these are about method components. Method components. Say, method name and arguments is called method signature. Return type and method signature is called method declarator. Open brace to close brace is called method body. Return keyword line is called return statement. This totally called method definition. Whatever arguments you passed here, formal arguments or formal parameters. For calling this definition, we return two statements. These two statements are called method call statements. What are the arguments we passed in method call statements are called actual arguments or actual parameters. That's it. These are about method components. We'll see continuation tomorrow. Okay. Assignment 1 week back I shared, not two classes, last two classes. You can check the Google Classroom. Anu. You can check the Google Classroom. Long 1 week back I shared.